Hello everyone, my name is Jinesha and I'm representing our team consisting of myself, Umang and Akhil Chawla. Today we'll be presenting our progress on the deep learning based satellite imagery analysis project for tree identification and enumeration in the Gir forest. This is our final update for the project and we'll be focusing more on the baseline model implementation and its comparison with the actual model which we use right now. Talking about the agenda today, in the next 6 minutes, I'll briefly cover over the motivation, data sources, methodology, model architecture, initial results, and comparison to our baseline approaches. Let's move on to the motivation and the problem statement. So, in the Gir forest last century, there was an endangered species of Asiatic lions, making it an ecosystem of critical importance. However, the region faces significant ecological pressures as development competes with conservation efforts. Traditional manual surveying methods are time-consuming, expensive, and provide very limited geographical coverage. Our project aims to develop an efficient, scalable tree mapping solution using deep learning techniques, which will support more informed conservation decisions as well. Talking about the data source, our training data, we used augmented forest segmentation dataset from Kaggle, which consists of approximately 5,000 high-resolution satellite images, which which are manually labeled along with their mask. Each image is approximately 5 into 5 into pixels in resolution, providing diverse terrain representation. This dataset serves as a foundation for our developing and evaluating our models before applying them to the Gir forest specifically. Talking about the input output, we satellite images are RGB images, which are 5 into 5 into pixel resolution with three color channels, capturing various terrains and vegetation densities. The output of our model is binary segmentation mask, which distinguish trees from non-tree areas plus the tree count estimates. Our baseline implementation uses random forest classifier, which we compare against the deep learning based. Now, my friend Akhil will continue.
So going on to methodology and metrics, we've implemented a two-stage approach. First, forest coverage segmentation, and second, individual tree enumeration. For evaluating segmentation performance, we are using intersection over union, F1 score, and pixel accuracy. For tree enumeration, we measure mean absolute error, root mean square error, and relative error percentage to assess counting accuracy. Next slide. Going to the unit semantic segmentation model, our primary model is a unit architecture, which consists of a encoder for downsampling and a decoder for upsampling. The encoder has four blocks, each containing a 3x3 convolution, followed by ReLU activation and max pooling, with feature maps increasing from 64 to 512. The decoder also has four blocks for with transpose convolution and skip connection from the encoder, with feature map decreasing back to 64. The final layer uses a 1x1 convolution with sigmoid activation to provide a binary mask of the same size as the input image. Next slide. So the unit model workflow, the diagram illustrates the flow of information through the unit architecture, highlighting the skip connection that preserves spatial information throughout the network. Next slide. So hyperparameter tuning and model optimization. So here we conducted extensive hyperparameter tuning to optimize the model performance. After testing various configurations, we settled on a learning rate of 5 into 10 to the power minus 5, batch size of 64, dropout rate of 0.2, minimal weight decay of 10 to the power minus 6, 64 base filters, and training for 50 epochs. These parameters provided the best balance between the model accuracy and computational efficiency. Next, my friend Umang will be continuing.
So going to performance comparison with the baseline model. So our baseline model was random forest. So compared to random forest baseline model, the unit model shows significantly improved performance. The random forest struggled with spatial contrast and had high error rates in dense forest trees clusters. In contrast, our unit demonstrates higher segmentation accuracy, better generalization across various ranges, and more accurate tree counting in both sparse and dense vegetation across. And moving on, segmentation performance metrics, if we see, uh, This chart illustrates our segmentation performance metrics. As you can see, UNet model consistently outperforms our base model, and particularly significant improvement in the IOU scores and FN scores. And moving on to tree enumeration and error metrics. Looking at the tree enumeration specifically, our error metrics show substantial improvement with UNet approach. We reduced the mean absolute error RMSE by approximately 40% compared to baseline, and relative error percentage by decrease was by some 18% and standard to 11%. And moving on to our project demonstration. As you can see, there are four columns. First is the original image, and then is the unit segmented image, and there is the watershed algorithm provided image, and there is the graph-based algorithm image. And moving on to the prior work description, what we have. So our team has experience with UAV imagery segmentation, but no one has experience with satellite image, which was new for us. And moving on to the references. The first provides the reference to the data set, and next all are the reference we use for our model training. And thank you for listening.